All right, let's jump straight into this explainer. Today, we're unpacking a really crucial 2026 specification straight from Google Cloud's Data Cloud team, the Open Knowledge Format, or OKF. Look, if you work anywhere near data architecture, documentation, or AI, you already know the pain. Keeping your systems fed with the right information, it's a massive, massive headache. So we're going to look closely at a standard that was designed specifically to cure that headache, basically bridging the gap between human readers and AI agents.
But before we get to the actual technical specs, ask yourself something. How do you stop reassembling knowledge from scratch every single time you build a new AI agent? I mean, think about it. You've got human experts writing documentation, and you've got AI models trying to read it, but they literally do not speak the same structural language. And the result? Constant, exhausting re-engineering.
So to tackle this, here is our roadmap for today's explainer. 1. Solving knowledge fragmentation. 2. Meet open knowledge format. 3. Anatomy of an OKF bundle. 4. Rules and compliance. And finally 5. What OKF is not.
Let's kick things off with Section 1, Solving Knowledge Fragmentation.
Information in almost every organization today is just scattered everywhere, right? You've got structured data catalogs, sprawling company wikis, deeply embedded code comments, and let's be real, sometimes the most crucial context is just locked away inside some developer's head. This means your AI agents are constantly hitting roadblocks, trying to parse internal data. Imagine deploying an intelligent search agent only to realize, hey, it can read Jira tickets, but it's entirely blind to your engineering specs and Confluence. Without bespoke, custom-built tooling for every single new repository, the AI is effectively flying blind. It just can't connect the dots across your ecosystem.
And the cost of this fragmentation? It is absolutely staggering. If you're building an AI agent today, you simply don't have the time or resources to constantly reassemble custom data pipelines just to read standard documentation. Every time you point an agent at a new wiki, you're forced to build new parsing logic. We're talking custom Python scripts, regex nightmares, and these incredibly brittle pipelines that completely break the second someone changes a page layout. It's profoundly inefficient, practically unscalable for the enterprise, and it pretty much guarantees the critical knowledge stays locked in those disconnected silos. Which brings us to Section 2, Meet Open Knowledge Format.
So the fundamental point here is that OKF is a concrete standard format. It's completely open and it's vendor neutral, which is huge because it ensures you're never locked into a specific provider's ecosystem. OKF represents knowledge in a beautifully simple way. It's basically a structured directory of UTF-8 markdown files equipped with YAML frontmatter. It was engineered from the ground up to be authored by human experts, generated natively by AI agents, and seamlessly consumed by both. And the best part? Achieving this interoperability doesn't require any proprietary SDKs or heavy runtime environments. It literally relies on the simplest foundational technologies of the web.
Looking at the timeline, version 0.1 of OKF was officially published by Google Cloud authors Sam McVitie and Amir Hermati as a draft back on June 12, 2026. And the technical roadmap here is structured around a highly predictable versioning scheme. Minor bumps will focus purely on adding backward-compatible fields, while major bumps are reserved for significant shifts, like renaming required fields. This kind of predictable stability is exactly what gives large organizations the confidence to start building tooling and adopting the format right now, knowing their investments are protected by a clear, transparent path for future growth.
Moving right along to Section 3, Anatomy of an OKF bundle.
Think of a knowledge bundle as a meticulously organized digital filing cabinet. It is a self-contained, hierarchical directory tree. The bundle itself is your unit of distribution, whether you're sharing that as a Git repository, an S3 bucket, or just a simple zip archive. Inside this bundle, the core unit of knowledge is called a concept, and that maps directly to a single markdown file path. Now, every single document is divided into two distinct, highly functional parts. Sitting at the very top, clearly delimited by 3 dashes, is the YAML frontmatter. Think of this as the strict, queryable label on the outside of the drawer. It holds structured metadata, like the document type, the title, and associative tags. This is exactly what the machine reads to instantly categorize the file. The second part, well, that's the markdown body. That holds all the rich, free-form text inside. So you can imagine storing your strict API dependencies up in the YAML for instant machine parsing, while the markdown below contains the human-readable deployment history, tutorials, and all that broader context. The true power of this anatomy really lies in its interconnectedness. A concept's identity is literally its file path. So tables/users.md simply becomes the concept identifier tables/users. By relying on standard markdown links to connect these concepts, you transform what looks like a flat, basic directory structure into a deeply connected, relationship-rich knowledge graph that an AI can easily traverse. You can even include formal citations in there, linking claims made in your text directly to external sources or internal research papers, which gives your AI agents built-in verifiable traceability.
All right, Section 4, Rules and Compliance.
There is a strict yet incredibly elegant rulebook here. First, every single non-reserved file needs that YAML frontmatter to parse correctly without throwing an error. Within that frontmatter, it absolutely must declare a type, meaning, is this document representing a database table, an API endpoint, a high-level business metric? But crucially, the rules for consumers, like your AI agents, force them to be highly forgiving. They must tolerate unknown type values, unrecognized keys, or even broken crosslinks. If a developer invents a brand new data type, older AI agents won't crash. They just gracefully ignore what they don't understand and keep parsing the rest of the bundle.
The compliance checks themselves are perfectly binary and incredibly straightforward. When a system evaluates an OKF bundle, there's zero ambiguity. Either your YAML frontmatter parses correctly, or it doesn't. Your type field is explicitly present, or it isn't. Furthermore, your reserved files, specifically administrative files like index.md and log.md, must conform entirely to the spec, or they fail the check. It's a clear, uncompromising pass or fail evaluation at the file level, which honestly makes writing validation scripts and continuous integration tests a total breeze for engineering teams.
Now, the genius of this intentionally permissive consumption model is the sheer system resilience it creates. Let's say one single file breaks the rules. Maybe a junior developer forgets that required type field. The entire system doesn't grind to a halt. Actually, scratch that. It doesn't even come close. That specific file simply gets downgraded and treated as a generic document. The AI can no longer filter or route it as a specialized typed concept, sure, but it absolutely doesn't invalidate the rest of your meticulously crafted knowledge bundle. The remaining conformant files survive, the graph stays intact, and your applications just keep running smoothly without any catastrophic failures.
And finally, Section 5, what OKF is not.
First up, we need to address a really common point of confusion. Despite sharing the exact same OKF abbreviation, the Open Knowledge Format and the Open Knowledge Foundation are entirely unrelated entities. One is a concrete file format specification published by Google Cloud, and the other is a global nonprofit advocacy organization promoting open data. They just happen to share an acronym, so definitely keep that in mind when you're searching for documentation online.
You might also be wondering, wait, doesn't schema.org already do this? Well, not quite, and it's a super important distinction to make. Schema.org gives you the shared vocabulary to describe things across the web, the specific types and properties you actually want to track. OKF, on the other hand, is the actual concrete container format. OKF natively references those external schemas, rather than trying to compete with them or replace them. Think of it this way. Schema.org is the dictionary defining the language, and OKF is the physical bookshelf where you structurally organize the books written in that language.
Lastly, you might already be familiar with the incredibly popular LLMS.txt file pattern that's been cropping up across developer sites. While both OKF and LLMS.txt aim to help AI systems read documentation, they operate at vastly different scales. An LLMS.txt is fundamentally just a single text file, acting as a quick guide to a site's top-level context. OKF is a comprehensive multi-file directory structure meant for exchanging massive amounts of highly structured, typed knowledge between complex enterprise systems. They serve entirely different purposes for entirely different scales of information architecture.
Ultimately, what you should take away from this explainer is the sheer utility and timeliness of this standard. OKF is bridging a massive operational gap in modern software development. By providing a highly portable format that requires zero proprietary vendor tools, it establishes a true universal language. Your human domain experts can continue writing documentation normally in Markdown, and your automated AI agents can instantly consume, route, and understand it via the structured YAML. It literally eliminates the era of endless, customized data reassembly.
So, as we wrap up this explainer, I'll leave you with this thought to ponder. We all know how frustrating and wildly expensive fragmented data silos are. But with version 0.1 of the Open Knowledge Format officially out there and available to use, what is stopping you from turning your organization's scattered information into a perfectly structured, AI-ready bundle today? The tools are now officially in your hands.